Okay, here we go. We are going to try to see if we can write 1/3.
All right.
Before we get going, what's your guess? Are we going to be able to do this, or do you think this is going to be not super easy?
Well, I think we should be able to do it because it's a binary system. You should be able to write, I think, any number
Okay.
in binary.
Oh, and by the way, before we do that, like, what is 1/3 in decimal system?
So it is 0.33333, and 3 is going on forever after the decimal point.
Nice. Okay. All right. So what are we going to do here?
Well, let's see. We can start, and we see that 1/2 is too big, 0. 1/4 is not too big, so we have 1/3 minus 1/4, which is 4/12 minus 3/12, so we end up with a 12th left over. So we have a 12th. And now an 1/8 is too big, and a 16th we can write. So minus a 16th. Now I think we have to multiply this by 4 over 4, so we get 4 over 48 minus 3 over 48. So we get 1/48 remaining. So 1/48. 1 over 32 is too big. 1 over 64 works. Now we have to again multiply this over by 4 over 4. One 192. Minus 3 over 192. So we have 1 over 192 left. After we did 64th. And then we have 1/28th, and looks like we've got a little pattern going. 0.010110, and then this would, we could add a 256.
Okay. So what's your conjecture then?
So 1/3 in binary is 0.01010101 repeating.
Okay. How do you think we could see if that was true?
Well,
So we definitely, just doing some calculations, it looks like we're going to get an infinite repeating decimal, just like we got in base 10, by the way.
yep.
So maybe it's not such a surprise that we could get an infinite repeating decimal with in this case, a pretty nice pattern.
Yep.
But how do we check? How can we check if this is actually 1/3?
Well, maybe if you add them, we know that 1/3 in binary multiplied, well, we know that we multiply 1/3 by 3, it should equal 1.
Mm-hmm.
So, all we have to do is, see, we have to multiply it by, we have to add 2 1/3s to it, and we do times 2 by shifting over in one place to the left, so 2/3 should be 0.1010101 repeating.
Okay. How did you figure that out? That's a pretty nice thing to notice.
Well, we think this is 1/3, so if we multiply 1/3 by 2, we should get 2/3. And multiplying by 2 in binary is just shifting over a place to the left.
Okay.
And let's see, if we add all of these together, we're going to get 0.11111111. And a half plus a fourth plus an eighth plus a 16th. We already think that is going to converge to 1. So
Nice.
we know this here, and then times plus 2 of it, so 3 of this pattern here is equal to 1, so it must be equal to a third.
Cool. Hey, that was great. That was really great reasoning. Well, it was pretty nice. So we now know even what a third is.
Yep.
And it gives us a sort of a procedure for calculating other fractions, like if we wanted to calculate a fifth or a seventh or something, we can see how it goes. All right, hey. Good work this morning, huh? High five.